Example, rewrite each exponential expression in radical form. Example A, x raised to the 1/3 power. We want to rewrite this as a radical. To do so, let's recall the definition that we just talked about. Recall the definition. A raised to the fraction m over n is equivalent to the nth root of a to the m power. So x raised to the 1/3, using the definition for rational exponents, is equivalent to, let's identify the bottom is the root. Remember, the denominator is our root, and the other number is our power. So x to the 1/3 is simply saying that we have the cubed root of x raised to the first power, which is equivalent to simply stating the cubed root of x. So x to the 1/3 power is simply the cubed root of x. Makes sense? Not too hard. Let's do example B. M raised to the 2/7. Again, using the definition, we identify the bottom number. Like in a tree, the root is at the bottom, so we have the root being the bottom number, the denominator. This is our root. So when we go to convert this into a radical, we want to write this as the 7th root of m, and then the 2 is the power that we have on m. So this is equivalent to the 7th root of m squared. All right, so let's take a look at this last example. Y raised to the negative 4/9. Now what makes this example more challenging is, of course, the fact that it's a negative exponent. But we know what to do with negative exponents in order to make them positive. Once we have a positive exponent, then we can just apply the definition much easier. So let's convert this negative exponent into a positive exponent. And how do we do that? The negative exponent simply takes our base and inverts it, right? So when we have y raised to the negative 4/9, that's equivalent to 1 over y raised to the 4/9 power. That's by the definition of negative exponents. Now we can convert this into a radical form. That's 1 over, and using our definition, the number in the bottom, remember, is our root. The top number becomes our power. So this rewrites as 1 over, and remember, the bottom number is the 9th root of 9. So this is the 9th root of y raised to the 4th power. So y raised to the negative 4/9 is equivalent to 1 over the 9th root of y to the 4th power. Let's now take a look at examples where we go in the opposite direction, where we start with radical expressions and convert them into exponential expressions with rational exponents. So let's take a look at our second example. We want to rewrite each radical expression as an expression with rational exponents. To do this, let's start by pulling up our definition that converts between rational exponents and radicals. Recall that a raised to the m divided by n is equivalent to the nth root of a to the m power. Going backwards, the nth root of a to the m is equivalent to a to the m over n. So looking at this expression here, see how it matches up? The 9 is our root, correct? The 9 is our root. And when we go to convert this into an expression that has a rational exponent, an exponent that's a fraction, remember our roots are our denominators, right? So we are going to have the 9th root of x to the 4th translated into the exponential expression x raised to the fractional exponent, where 9 is our root And like the roots of a tree, the 9 is in the bottom or the denominator of our fraction. And the 4 is our power, so that goes on top. The 9th root of x to the 4th is equivalent to x raised to the 4/9 power. How about part B? We have the cubed root of yz squared. Now there's a couple ways that we can break this up and dissect it. Let's first of all take a look at this in terms of this definition here. So what I'd like to do is rewrite this just so we can see more clearly that this is the same thing as y to the first power, right? Z to the second power. And now let's take each base separately and apply this rule, this definition. I have y to the first power inside a cubed root. So when I go to rewrite it, first of all, I have to remember that this number outside is my root. And remember, the roots are the denominators of our fractions, right? The roots are the denominators of our fractions. So if we take y and we raise it to a fractional exponent, the root is on the bottom, right? And then that power would be on the top. So this is equivalent to y to the 1/3. And then let's take the base z. And again, it has a fractional exponent. The power on z is 2. And the root is 3. That always goes in the denominator. So the expression cubed root of yz squared is equivalent to y to the 1/3, z to the 2/3. See that? Now I will comment that it's also equal to one other thing. If we think about our rules for exponents, we notice both of these have a denominator of 3. So we could also group the y and the z together into one big group that has a fractional exponent with 3 in the bottom. And on top, we would have y to the first, z to the second. Do you see how this and this are the same thing? Because our power to the power rule would tell us that y to the first to the 1/3 power is 1 times 1/3, which is just 1/3. And z to the second to the 1/3 using the product rule would say 2 times 1/3, which is 2/3. These expressions here are equivalent and they mean the same thing. And do you see how you could also directly go from there to here? How the cubed root becomes the 1/3 power, and inside you have yz to the second. Just another way to look at that. Finally, let's take a look at example C. We have 1 over the 4th root of 2a. So, using that idea that I just talked about, let me rewrite this as 1 over, now I have 2a, so all of 2a being raised to the 4th root. This is 2a to a 4th root. And a 4th root is designated by a fractional exponent 1 over 4. This means the 4th root. So we have 1 over 2a to the 1/4 power. That is perfectly acceptable as having an expression with rational exponents. But just so we know that there is an equivalency, I can rewrite this to have a negative exponent, can't I? This is the same thing as taking 2a and raising it to the negative 1/4 power. Is that correct? Right? That's our definition of negative exponents. Tells us if we bring our base up to the numerator, then we have to change the sign on our exponent. 2a to the negative 1/4 is equivalent to 1 over 2a to the 1/4, which is the same thing as 1 over the 4th root of 2a.